All right, so I've added this. It's not in your notes. It's just a video that when you're doing your study plans and you come across this problem, that instead of me having to answer it over and over again, I go ahead and walk you through a similar example in the video. So we've talked about composite shapes and how we just need to look at the shapes and figure out what we need in order to or what shapes we have, and then what formulas, and then take from there what we need. So on this, we have we want to find the surface area of the solid where the cone is hollow. So what it's saying is we have not only the outside of the cylinder and the outside of this hemisphere, half a sphere, but surface area would also include this cone on the inside because that surface would be exposed. And so when it comes to this one, we need that hemisphere. Again, that just means half a sphere. Oops. Helps if I could spell. Hemisphere, we need a cylinder. Cylinder. And we need a cone. Now, as we always should do, we should look at what pieces are, do we have one base or two bases? Do we use none of the bases and it's just the lateral area? Hemisphere is just straightforward surface area of the sphere, so 4 pi r squared, but then you divide that by 2, so a hemisphere would just be 2 pi r squared. And then when it comes to a cylinder, our surface area formula is normally 2 pi r squared plus 2 pi r h. But when we look here, the base is covered by the hemisphere, so we don't need the top base. And the bottom base is open because that's the opening of the cone. So we don't need this pi r squared h. Pi r squared, 2 pi r squared. We just need the 2 pi r h because that's our lateral area. Oops. I really wish it would stop doing that. All right. I guess that's not what I'm going to write today. Lateral area. All right. And then for a cone, surface area equals pi r squared plus pi r slant height. Now, again, base of the cone is open, so I don't need the base. I just need the lateral area. So when it comes down to it, when I'm finding the surface area of this entire shape, I'm doing the surface area is 2 pi r squared, that's the hemisphere, plus 2 pi r h, which would be the lateral area of the cylinder, plus pi r slant height for the lateral area of the cone. That's like, if we were to make a formula for this shape itself, that's my formula. Okay, I just took what I knew from the other pieces and put them together. So, what are things that we need? We need a radius, we need a perpendicular height, and we need a slant height. Well, the radius for all of them, the diameter is 4, right? So the radius is going to be 4 divided by 2, which is 2. So my radius is 2. My height of the cylinder, because that's the only one, and the cone, but more so for the cylinder right now, is 11. So the height of the cylinder is 11. Now the slant height, that's where I'm creating this right triangle. I drop this straight down, I bring this over, that's 2. This is 11. I need to find this side right here. And so we're going to find that slant height. We're going to do 2 squared plus 11 squared equals that slant height squared. We're using Pythagorean theorem because this is a right triangle. And so we have 4 plus 121. And then that becomes 125. So that's L squared equals L squared. And then we have to do the square root of both sides. So my L is the square root of 125, which is what it's not a perfect square, so that's what I'm going to leave it at for now. Square root of 125 meters. So those are the pieces of information I need. So I'm going to start with the hemisphere. I'm going to take 2 times pi times 2 squared, and I'm going to end up with 2 times 4 pi, which is going to be 8 pi, which is approximately 25.12. All right, so meters squared. So that's the hemisphere, which I just realized I misspelled. All right, from here we want the cylinder, in which all I need is this 2 pi RH. So we're going to have 2 times pi times our radius is 2, and the height of the cylinder is 11. So 2 times 2 is 4 times 11 is 44. So we have 44 pi, which is approximately 138.16 meters squared. All right, and then lastly, my surface area for the cone, which I'm doing, add 2 on the brain. Which we're doing pi r h, or r slant height. So pi r slant height. So then that's going to be pi times 2 times the square root of 125. And so when we multiply those together, we're going to get approximately 70.21 meters squared. And I'm going to be honest, if I didn't have the square root here for the 125 and they were all whole numbers, I would have just found 8 pi, 44 pi, whatever this other one could have been in terms of pi, added them all together and then multiplied by 3.14, because then that's going to give us a more accurate answer. But because this is a square root and it was already an irrational number, we just went ahead and did the rounding of all of them. All right, so from here, we're just going to take 25.12 plus 138.16 plus 70.21, and when we add those all up, we get 233.49, and then it wants us to round to the nearest whole number, which is approximately 200. I look at the 4 does not round the 3, so 233 meters, no, do not end, meters squared. And so then that is our final answer. So again, I just looked at what I knew. The reason I chose this one is it has that hollowed out, so what does that mean for surface area? But it doesn't change what we're doing. We're looking at what shape formulas do we need, and then how much of that formula do I need? Do I have both bases? Do I only use one base? Am I half of the sphere? Am I a cone with no base? That's really the only thing that kind of makes this any more difficult, is some of them were, most of them were not using the entire part of our formula. So I hope this helps you get your study plans completed, and I will see you in class. Until then, 8th grade.